Question 1. What's the formula that you use for number 1? Acceleration is force divided by mass. So if the mass is bigger, then the acceleration is going to be smaller, right? And which one is going to have a bigger acceleration? The 4 kilogram. And how many times bigger? 2.5 times. How do you get the 2.5? 10 divided by 4 is 2.5. Make sense? That's all there on that. All right. Number 2. Well, the formula for G, is it on your formula chart?
I don't think so.
G is equal to Gm divided by square of the radius. That's on the surface of the earth, and at a height, that is the formula. So,
I was just wondering, are we going to be able to look at the way you work these questions out?
yes, it will be on YouTube today. So, that's why I'm doing it this way. Okay, so G is Gm by r squared, G prime is Gm by r plus h, the whole squared, correct? And I'm going to divide. When I divide, what terms are going to get cancelled? Yeah, what's going to get cancelled now? Now you have to stop and listen. Come on. G prime by G is Gm by. This one is going to be, see, I divided G prime by G. So, when you divide, you know that the second term is flipped over and multiplied. You know that? So that's why I flipped over the second term, which in this case is this one. Isn't that the second term? That's flipped over. If you look on this side, it's flipped over here. Right? This flipped over. So the masses get cancelled. And then, what's the height given in that question? What's the height?
Equal to the radius.
It says it's equal to the radius. We need not even put the number down. All that we need to do is to put h is equal to r. Because the height is given as the radius, isn't it? So in the next step, you put it as,
R squared over 2r squared.
put h is equal to r. And so now it becomes G and M got cancelled, so you get r squared plus r the whole squared, which is 2r the whole squared, isn't it? 2r the whole squared is 4r squared. And so now the r squared and r squared get cancelled, and you get 4. On the left hand side, you have G prime by G is 4. So G prime is G by 4. Question 3. Potential energy at the top is equal to kinetic energy at the bottom because there is no friction. And what's the formula for potential energy? mgh. Kinetic energy is 1.5 times the mass times the square of the velocity. The masses get cancelled. Rearrange to get h is v squared by 2g. Plug in the numbers. Didn't it say 9.8 squared divided by 2 times 9.8? One of the 9.8 gets cancelled. That's why I did it that way. And then you get 9.8 by 2, which is 4.9 meter. Number 4. Like I said, inelastic collision. Perfectly inelastic collision means sticking together. And then conservation of momentum. Remember that formula? MAVA plus MBVB is equal to MAVA prime plus MBVB prime. But in this case, they are sticking together so you can add the masses like I've done. They have a common velocity, don't they? Because they're moving together. They only have one velocity, and then plug in the numbers. 2 times 4 plus the other one is not moving. That's why it's 0 is equal to this. And you get 8 divided by 4 is equal to 2 meter per second. You should not even have taken 2 seconds to do that. But the question goes on to say, what is the loss of kinetic energy? How do you find the loss of kinetic energy? Yeah, you find the kinetic energy before and then find the kinetic energy after, isn't it? Okay, that's what is done. Initial kinetic energy is 1/2 MAVA squared plus 1/2. You have to add the kinetic energy of both, don't you? Okay. But what's the kinetic energy of the second one? What's the kinetic energy of the second thing? Nothing, because it was not moving. So that's going to be 0. You get this as 16 joules, don't you? Well, what's the final kinetic energy? Final kinetic energy. Okay? 1/2 times. Can you add the masses now? Yes, they have the common velocity. So 1/2 times ma plus mb times the velocity that we got just now, which is 2 meter per second square, 2 meter per second. So plug that in. So because their masses are the same, 2 plus 2, 4. That's how I got the first 4, and then the 2 squared is 4, 8 joules. Therefore, losses, it was 16, now it's only 8 joules, so the loss is how much? 8 joules. Can't make it easier than this. Number 5. Momentum is mass times velocity. So initial momentum is mass times initial velocity. How much is that?
3.
0.1 times 3? That is
Times 30.
30. I mean 30. That'll be, he led me wrong. Okay, 3 kilogram meter per second. And what's the final?
0.1 times
0.1 times negative 24. Why negative 24? It's coming in the opposite direction. That's why. Don't forget that. So it's negative 2.4. And therefore, when you take the change, the two negatives are going to add up, isn't it? And you're going to get 3 minus 2.4, which will be 3 plus 2.4. That will be 5.4 kilogram meter per second. That's too slow. Okay, number 6. I put it a little different here. Remember, momentum is conserved only when no external forces are acting on it. You remember that? No external forces here. It's just an internal force. So I put MAVA is equal to MBVB. Strictly speaking, it should be negative because the other one moves in the opposite direction. Okay? Yeah. So 60 times 0.8 mass of the person times his velocity is equal to 100 times the velocity of the other one. So 60 times 0.8 is 48 is equal to 100. Divide 48 by 100, you would get 0.48 meter per second. How tough that can that be?
On the answer, it says
7. You only have a mass of 50 kilogram. You're skating at 4 meter per second. So your momentum is 50 times 4, right? MAVA plus MBVB is equal to. And can we, as you collide while holding each other, so you're sticking to each other. No way. So you do the same thing. You add the masses, multiply the velocity. So 50 times 4 plus 0. Why 0? Second person was not moving. Okay. So easy. 50 plus 40 times velocity. So that's 200. 200 divided by 90 is equal to 2.22? Yeah. So 2.2 meter per second is what we get. All right, that takes us to number 8. Did you reach number 8?
no.
Okay, I'll go up to number 8. Number 8, the constant force acting is 9 Newton. That's the formula. Force multiplied by time is equal to change in momentum. We have used that many times. Force times time is mass into change in velocity. And one of the velocities is given as what? You're not even, no, the velocity is not given. You're just asked to find the change of velocity. Isn't V minus V naught the change in velocity?
Yeah.
So that's what you're trying to find. So you get 3 meter per second. Again, repetition. Is there friction in that question? No. Potential energy at the top is equal to kinetic energy at the bottom. That's all. mgh is equal to 1 half mv squared. V squared is 2gh. Velocity is square root 2gh. 2 times g times 50. So 2 times 9.8 times 50. That gives you 980. So take the square root of 980, and that should give you 31.3 meter per second. Is that the question? Okay. You have force and you have displacement. And how do you find work? Work is work is force times displacement, but you have to find the area of that curve, under the curve. So take note of that. You have to find the area. Now, how do you find the area of that? What kind of figure is that? Okay, how do you find the area of a trapezoid? Yeah, you can even do it that way, 2 triangles and a rectangle, but you can do it in one step like this. Can anybody tell me what's the length of the base? What's the length of the upper parallel side? 2. Don't you see that it's 2 and 4? So the distance is 2, isn't it? So you take 1/2 times, oh, I was marking that, 6 and 2. 1/2 times the sum of the 2 bases, that is the parallel sides, 1/2 times 2 plus 6 times the height. Can you see that the height is 20? That's all. So you get it in one step.
Couldn't you just find the area of the square multiply times 2?
Okay. Number 11. Again, change in potential energy is equal to work done, isn't it? Although there is friction, we are first assuming that there is no friction. If there was no friction, then change in potential energy is work done, correct? And then it would be mgh is work done. And remember, 800 Newton is m times g. So 800 times 2, 1600 joules is the work done. Is that clear? If there was no friction, that is how much work should have been done. But the question says, how much work was actually done? Go back to the question. Look at the question. How much work was actually done? 3200 joules was done. Now tell me why you had to do extra work. Because of friction. So this was the work that you should have done to get the box up there if there was no friction. Now you had to do double this. So what you do is you take away, you find the difference. 3200 take away 1600 will give you the work done against friction, wouldn't it? The difference would give you the work done against friction. So here the work done is 3200, hence work done against friction would be 3200 take away 1600, which would be 1600. Okay, now what? What's the last step? If you know the work done against friction is 1600, what's the formula for work? Force times displacement. So you're talking about the frictional force times the displacement should be 1600. And you already have the displacement. What's the displacement? 4. That's all. So work is equal to force times displacement. 1600 is force times displacement is 4 meters because the plane is 4 meters long. Therefore, you divide and you get it as 1600 divided by 4, which is 400 Newton. That's it. Newton. I'm assuming that you read the question. The most important thing you have to remember is this. Work done is equal to either change in potential energy or change in kinetic energy. In this case, it's equal to change in kinetic energy. Work done. So F times delta X is equal to 1/2 times V squared minus V naught squared, because that's the change in kinetic energy, isn't it? The force is given as 200 Newton. Multiply by 10. is equal to that. And what's the initial kinetic energy? Anybody? In that question, what's the initial kinetic energy? 0? Yeah. So that's why you have a 0 there. And so 1 half mv squared is equal to 2000 joules. So final kinetic energy is 2000. Here's number 13. Gravitational, we are into gravitation now, and the formula for gravitation is this one. F is g m1 m2 by square of the distance. And if the distance becomes half, what happens? Yeah, the square makes it 4, and the 4 goes to the top. The 4 goes to the top, isn't it? Because it will become r squared divided by 4. So that 4 goes to the top. So F is, oh, I should have put F prime is 4 times F. Okay, I said verge of slipping means it's just balanced by friction. So we can find the force of friction. Force of friction here must be equal to the centripetal force, which must be mv squared by r, isn't it? Centripetal force. Okay, so that is 400. Where did I get that 400 from? Somebody. Where did I get the 400 from? 20 squared, yeah. Because the mass is not given, is it? So m times 20 squared, which is 400 divided by the radius 80. Okay. That gives you 5 times m. That is case 1. Okay, case 2. What's the difference in case 2? What's the radius? 320. Now just tell me, will he be able to go faster or slower with the same friction? Faster, because that's not as sharp as 80 meter, right? 320. So do the same thing. Case 2. Now we know the force of friction is 5 times m, isn't it? It's the same friction, okay? Same friction, so 5 times the mass is equal to mv squared by r. Again, the masses get cancelled. You're looking for the velocity. Make that the subject. 5 times 320. 1600. Take the square root of that, and that should give you 40 meter per second. Again, maximum speed 30 kilometer per hour. Do you have to change? No, because the answer is also in kilometer per hour. So keep it as 30 times 30 squared by r. That's equation 1. And next time the radius is twice, isn't it? So you put it as 2r. You know it's the same force, so you equate them, cancel the mass and the radius, and you get velocity squared is 30 squared is 900 times 2, 1800. Take the square root of 1800 and you have your answer. .4 kilometer per hour. It's a very important question again. T is 2 pi r by the orbital velocity, and that velocity is square root gm by r. I think that's on your formula chart. The orbital velocity formula is on your formula chart. So plug in that here and square both sides, because we want to get rid of the square root. So square both sides. T squared is 4 pi squared. Where did I get that r cubed from? Because this square root will vanish, isn't it? This will become r squared, and this r will go to the top. So r squared times r is r cubed. Making any sense? Because this r is under the square root vanishes, and then, okay. So make mass the subject. It's 4 pi squared r cubed by gt squared. That's it. Now plug in the numbers. But be careful. You have to change your kilometers into meter, change the days into seconds. So 4 times pi squared times. Remember, that's because it's changed into meter, isn't it? It's 422 times 10 to the 3 becomes 10 to the 6. Okay. And then 1.77 days. How do you change? Times 24 times 3600. And do not forget to square it. Yeah, when you do this calculation, be careful. There's lots of stuff here. Cube and square and all that. Got to be really careful. And 1.9 times 10 to the 27 kilogram. Here it is. Work done is equal to change. You know that little triangle stands for change in kinetic energy, don't you? Delta. Okay, that's 1/2. To be perfect, 1/2 v naught squared minus. But you know that the final velocity is 0, isn't it? So, therefore, it's 1/2 times 100 minus 0. That is 50 times the mass. 100 divided by 2 is 50. And this is the work done against friction. But work done is also given by force times displacement. So 50 times mass is frictional force times displacement, which is 50 meters. So the force is 50 times the mass divided by 50. That will be the mass. Isn't it? What next? What are you asked to find? Coefficient. What's the formula for coefficient of kinetic friction? Friction is mu times Fn, isn't it? Okay. So friction is mu times Fn. Therefore, mu will be frictional force divided by Fn. I think I need to just write that down for you to see. Friction is given by mu times F times N, isn't it? So I just switched them and made mu is equal to Ff by Fn. That's all. And the frictional force is m, so m divided by. Oh, you know that the normal reaction is the weight if it's on a horizontal surface. So m times 9.8. Cancel and you get 0.11. I mean 0.1. Number 18, that is the diagram. See, I can draw 37 degrees, 100 Newton. The weight would be 40 times 9.8, which is 392. And the force that he applies, but the normal reaction would have been the same, 392, but that is 100 sine 37. Gilbert, are you getting it? 100 sine 37, which is 60.18 Newton. And so the total normal force is 392 minus 60.18, which is 332 Newton. Somewhat. Yep. 1 kilogram is 2.2 pounds. You might have one question. I mean, so 110 divided by 2.2 is 50 kilograms. You already did half of this problem. Force is mass times acceleration, or rather net force. Okay. A is 1.5. Per second squared, and these are the quantities given. Initial velocity is 15, final is 0. A is negative 1.5, and you have to find delta x. And what's the equation? Yes, V squared is V naught squared plus 2AX. Plug in the numbers and find your delta x. Or make delta x the subject. You'll get it as V squared minus V naught squared by 2A. Isn't it? And the answer? 75 meters.